Hi, I am Osman Anwar. I will be presenting our work titled Inverse Constraint Reinforcement Learning. This is joint work with Shahar Malik, Raza Agassi, and Ali Ahmed and will be presented at ICML 2021. AI safety is a growing concern. For agents to be safe, they need not only know what things to do, but also be aware of what never to do. However, manually specifying all such prohibited behaviors is not possible. In this work, we consider the problem of automatically learning constraints in the context of agents trained through reinforcement learning. We develop a method to learn constraints in high-dimensional continuous settings and demonstrate that constraints thus learned are transferable to other agents across morphologies and dynamics. For the presentation, we use calligraphic M, pronounced as simple M, to represent a typical MDP, as encountered in oral literature. Augmenting this MDP with some constraint set C gives us a constraint MDP. M and MC have the same reward function generally, but they still may differ in their optimal policies. We present the target constraint set with C star, which is known to the demonstration agent but unknown to the RL agent. Given MDP M and a set of trajectories D from a constraint abiding agent, our goal is to find the most likely constraint set that, when combined with MDP M, explains the behavior of the demonstrating agent. We assume that demonstrations follow maximum entropy distribution. Indicator function represents whether a trajectory is constrained or not. A trajectory is constrained if it contains one constrained state action pair. Notice that indicator function defines the membership function over the constraint set. So we are essentially interested in finding this indicator function. To do so, we propose performing a soft approximation of indicator function by using neural network zeta and parameterize the neural network with parameters theta. Under the maximum assumption, we show in our paper that optimizing average log likelihood is equivalent to optimizing the objective given here on the screen. This expression essentially targets at finding a constraint set such C under which both experts and our agents incur equal average constraint violations. We did our method conduct some experiments. Because on all three environments, lab grid world, half theta, and our method is able to train constraint abiding agent which also obtains higher reward. More importantly, we show that our constraint set once learned can be used to train other agents which may differ in morphology dynamics as well. For example, we transfer the constraint net for train acquired through ANT agent to morphology different point agent as well as dynamically different agent and token. As results are shown here, which shows that our method is the only one which is able to train these two agents successfully. Thank you for the time.